are actually going to look at solving related rate problems. We're going to carefully read the problem. We're going to draw a diagram. We're going to label it. Very first thing. Next thing, we're going to identify what we need and what we are given. Needed and given. Then we're going to write an equation. I'm going to let y'all read this, but in some cases you may have to combine one or more equations to get one. We're going to use implicit differentiation to find the derivatives of both sides of the equation. And then we're going to substitute any given values of the variables or rates of change, and then we're going to solve. My expectation is that for your solution, is that I have a picture, an equation, a derivative, and an answer. And the other thing is on here, since these are word problems, I need units. Please give me your units. So we're going to start out with, turn to the third page on here, which talks about volume of a sphere. That's the very first one we're going to do. So here's what we notice, is that a spherical balloon is inflated at a rate of 2 cubic feet per minute. At what rate is the radius changing when r equals 15? So there's our picture. There's my radius. R is going to equal 15 inches. And then, what else did it tell me? R is 15 inches. It also tells me that a spherical balloon is inflated at a rate of 2 cubic feet per minute. Well, cubic feet is volume, so that's going to be dV dt. And we have 2 feet cubed per minute. And then we want to know what rate the radius is changing. So we want to know dr dt when r is 15. Well, before I can do anything with this, we've got to fix my units. So feet cubed, let's actually just change that to inches cubed. So that would be 24 inches cubed per minute. So let's do this. Now we have our formula, which is 4/3 pi r cubed. So volume equals 4/3 times pi r cubed. Let's take the derivative. So dV dt equals 3 times 4/3 pi r squared dr dt. Remember, we did that the other day. 3's cancel, so now we have a new formula. dV dt equals 4 pi r squared dr dt. Okay, well, the next thing we want to look at, now we can start plugging in. All right, well, we know dV dt is 24, so we're going to say 24 inches cubed equals 4 times pi times 15 squared times dr dt. Well, 15 squared is 225. So this is 24 equals 4 times pi times 225 dr dt. Now we're just going to divide. We're literally going to divide by 4 pi times 225. So dr dt actually equals 2 inches 2 over 7 pi 75 pi inches per minute is dr dt. And that is roughly 0.084 inches a minute. So imagine if we converted that to feet, that would be a lot. So that is your answer. So what I will check for is I will check for, when I check these, I will check for your picture. I will check for your labels right here. I will check for your equation, your derivative, and your answer. So it's a 4-part problem, and each part will have equal weight. So even if you just draw a picture and put some labels on it on your quiz on Tuesday, you will get some points. Okay. Next part, we're going to move to the Pythagorean problem. So there are some things you need to remember here. The derivative of a constant is 0, and as the distance decreases, if distance decreases, rate is negative. So, Barney tricked a cat into climbing to the top of a 15-foot ladder. So let's make this a ladder. And then we have little kitty at the top. Stick a tail on it, okay? There's our cat at the top of the ladder. And it's 15 feet. Alright? Leaning against the side of the building. Barney began pulling the ladder away at a rate of half a foot per second. So, now is that an X rate or a Y rate? It's a Y rate. So we're going to say dy dt equals 1/2 feet per second. Okay? Now the next thing we're going to say, when the ladder is 9 feet from the base of the building, so we also know y is going to be 9 feet. How fast is the cat plummeting towards the ground? So we want to know when the ladder is 9 feet from the base of the building. So that actually should be my x. Alright, my horizontal. Alright, and let's call that dx dt. Okay, so I can say this is x squared plus y squared equals c squared, right? And we want to know how fast is the cat plummeting towards the ground. So we want to know dy dt. Well, what's the first thing I'm going to need to do here? Alright, I know for my equation x squared plus y squared equals 15 squared, right? Well, I know x equals 9, but I've got to figure out y. So let's plug in and figure that out. That's the very first thing I need. So 9 squared plus y squared equals 15 squared. You end up with y equaling the square root of 15 squared minus 9 squared, which is just y is literally 12. Okay, so now we have values for everything. Just a reminder, these are in feet. So the first thing I'm going to do is, alright, I'm going to go back to my formula. It is x squared plus y squared equals 15 squared. Take the derivative. Okay? And what's the other information I know? I know dx dt is half a foot per second. And I want to know dy dt. Okay, so let's take the derivative. 2x dx dt plus 2y dy dt equals 0. Okay, so now let's plug everything in. 2, well, times x, which is 9, plus times 1/2, plus 2 times 12 times dy dt, which is what I'm looking for, equals 0. Well, now, oops, sorry. I'll let y'all catch up a second. All I did here was, again, I plugged in my values. Okay? dy dt was 1/2. X was 9, and y was 12. So now let's flesh that out a bit. Well, my 2 and 2 will cancel, so I have 9 plus 24 dy dt equals 0. Solving for that, 24 dy dt equals -9. Solving, divide by 24, dy dt equals -9 over 24. That simplified is -3 over 8 feet per second. because we're pulling out at feet per second. And again, remember when you're solving for a rate, it's a something per a something. And that is your answer. Again, your 4 parts, your diagram, your etc. Be sure you have those. There's your derivative, there's your equation, your pictures up at the top, and your answers over here. Those are the 4 things I will grade.